Hello folks and welcome. As you might be knowing my intro through the Lear documents when you have registered for the course, I am Professor Manoj Tiwari. I work here at IIT Kharagpur. Through this course onto water economics and governance, what we will be discussing primarily is the concepts and various practices onto the for the management of issues related to water economics and governance. Water is one of the most essential component in our life, in the ecosystem, in the entire universe in fact, and it is the issues or the discussions related to water are not new. If you see, there has been age old literature from the ancient. Even the what you see on your screen is basically one of the suktam from Rigved on water, which says apo hishtha mayo bhuvastha na urje dadhatana maheranath chakshase. What it refers to or what it means is that it sort of says for water that only because of the presence of water, this entire atmosphere is so refreshing and imparts us with vigor and strength. And it pays river who sort of gladdens us by its sheer pure essence. So that is the value of water which has been recognized from our almost one of the most ancient literatures. Coming on to this course, so before we go into the details of discussion on what are the what specifically we will learn throughout this course, let us first talk about why we should bother about water management at first place. So there are several reasons for which we are sort of enforced to look for better water management, we would say. So the basic reason is, one of the most basic reason is that fresh water is a very limited natural resource. There is plenty of water in the universe, and we will talk about detail in terms of the quantity also over the sections when we go there. But in general, most of us are aware that most of the water what we have in the universe lies in the oceans, and which is not worth using without proper processing, or what we call in engineering terms is treatment. So and which is quite a costly and difficult affair. So the fresh water that is available is very limited. How much it is we will discuss when we go on to those specific sections, but the fresh water, what the point is that fresh water is only in the confined spaces and only in the limited amount. However, it is the fresh water which is sort of fundamental to life, livelihood and sustainable development. Now, sustainable development, what essentially means that we sort of we grow in such a manner, we develop ourselves, or all our basically human life development, infrastructure development, industrial growth and all that. So whatever development activities are there, we should plan it in such a way that we do not hamper, we do not sort of kind of quantitatively or qualitatively degrade our natural resources. Now, what means the qualitative and quantitative degradation of natural resources? Particularly, we will focus onto the water, as that is the focus point for the discussion. So, qualitative and quantitative degradation of water means we should not spoil the water quality of our river, ponds, lakes and groundwater, which is one of the major problem these days. You see that the quality of water that are in our sort of most prestigious rivers, Ganga, Yamuna and all these the major rivers these days, there is so much of talk onto the deteriorating water quality in these rivers. Apart from that, there is a loss or there is a degradation in terms of quantity as well from rivers as well as from groundwater. Similarly, quality aspect from rivers as well as from groundwater. So, this is not a sign of sustainable development. The sustainable development essentially targets that we grow, we develop in such a way that our resources are not degraded. They sort of we leave the same or same amount and similar quality of resource to the next generation that are going to follow us. So, in a way we should ensure both intra as well as intergenerational equity. That is what sustainable development essentially means. Now, if you see that apart from this, there is no development activity which can take place without water having in its life cycle at some phase. Some may basically need it at a very beginning or manufacturing phase, some may need it towards the disposal or management phase, some may need it in almost in the entire phase. So, whether it is a natural process, ecological process or engineering process, any infrastructure development, any constructions, any material production, mining activities, whatsoever you name anything, and there would be certainly some requirement of water at some stage or some point of time. So, the purpose of basically saying this is that we will need water for future development as well, we will need water for growth. Now, as we were just saying that although we will need water, we should utilize this in a sustainable manner. After all this, what we see that our water sector is facing ever growing demand. Why? Because as just we were referring that there is no development activity possible without water resources, and there is a age for growth or development for several underdeveloped or developing countries, even in the developed world as well. So, there is lot of growth happening, and that is leading to lot of demand of water. Our lifestyle is changing, our facilities, infrastructure, the way we used to operate is changing. People earlier used to take bath in just say let us say bucket and all that. So, maybe couple of buckets of water 30-40 liters they used to basically take bath. But what you observe these days that they will use their bathtubs in the swimming in their bathroom, or use showers which operate for 10 minutes, 20 minutes, how long who knows. So, and then there are jacuzzis and all that coming up. So, the point is that you see with the practices or with the sort of growth, the requirement of water is also changing, it is shifting, and the shift is mostly from lower requirement towards higher requirement. So, the per capita demand, what typically we call in terms of water engineering, the per capita demand means per head requirement of water, okay, or if we say that per capita demand per day, which is termed as LPCD, liters per capita per day, is typically increasing. Apart from our sort of daily life, there are lot of industrial activities, new industrial activities and all that coming up, infrastructural growth is taking place, and all of this needs water. So, overall the demand of water is increasing for almost all sectors, be it industrial, be it domestic, municipal sector, recreational activities, or even agricultural. So, demand of water is increasing, however, resources are limited. Now, this calls for concern, and that is why we bother about water management, that how nicely we can manage our water resources, our existing freshwater resources in a manner that we can able to handle this growing demand in a sustainable way. That is all about water management basically. Now, why we learn water management, as continuing what we discussing earlier, is basically you see India is a developing country and there is a lot of demand of resources for development activity. We need to have a balanced approach so that we lead to minimum impact on environment, primarily on natural water resources, what we mean to say. So, we grow or we develop in such a way that we lead to have minimum impact on environment. The growing population and higher standards of living leading to higher water demand, the point what we are discussing just earlier, is increasing pressure on water resources, and as an engineer or manager or professional from whatsoever stream one is, one needs the basic understanding of all the associated concerns with water and the major ways with which one can manage the issues related to water and make critical decisions related to the development activities. We do not want, one does not expect to stop all the development activities for the purpose of securing or saving water. At the same time, we should not allow unjudicious uses of water, so that we end up leaving nothing for future generation. That is what has happened with coal. All of us are aware that we have been exhaustively using coal for our energy requirements, and the time now has come that the entire coal reserve will last barely 150 years more. So, what will be after that? So, that is sort of a prime example of unsustainable development, and the current water management practices or current water uses also are onto similar path, which one should avoid. What are the basic dimensions of water management is sort of, if we see the study of water management, or holistic study of water management, how water should manage. So, the study of how water resources maintain life, there are two aspects: what effect water causes on us and what effect we cause on water resources. So, that in an integrated manner needs a broad interdisciplinary perspective. So, one need to sort of one need to understand that how water resources are helping us in maintaining life, maintaining ecosystems, maintaining our growth, and in turn what effects we humans are creating through various anthropogenic activities onto the natural resources of water. For understanding this, as we were saying, that it is a interdisciplinary, we need a interdisciplinary perspective, and the problems and their associated solution related to the management typically will involve multiple disciplines. There are basically social aspects of water management, political aspects, economic aspects, actually at times even religious aspects are also there. When we talk about the managing of water in river Ganga or cleaning of Ganga, or basically sort of controlling several activities, pollution leading to Ganga, there is a lot of religious aspect involved. So, at times we may even may not be valid for all water resources, but for few, and at times there are these religious aspects are also there, which you can club of course with social aspect though. So, there are social aspects, political aspect, economic aspects, apart from the well known engineering and technological solution. So, we are not no one is denying that engineering and technological solutions are not needed for managing water. Of course, we cannot manage it without sound engineering and technological knowledge, but apart from that there are a social, political and economic angles involved, and that needs to be considered while we target a holistic management of water. The present course primarily focuses on this, your social, economic and political aspects. So, economics and socio-political governance of water is what basically we will be looking after in this course. That is basically our prime objective, prime target. Now, so far we talk about why we should learn water management, what is there in the water management, what is the importance of having multiple disciplines in the water management. Now, coming on to the specifically the objectives of learning water economics and governance, which is focused onto this course. So, the major objective means of learning water economics and governance, because engineering and technological solutions are being taught since quite some time, since several decades now. However, generally many times people overlook the economic aspects, social aspects, governance aspects, how difficult it is to govern water. So, all those aspects are many times overlooked. This course primarily focuses on to those things within objectives of learning for water economics and governance. Is the first and foremost is to develop an attitude of concern for water. Now, when we say that develop an attitude of concern for water, it means one want to one must in fact understand what is the value of, what is the economic value of water. Okay. When somebody opens a tap while brushing, he might be wasting some 10 liters of water because he is not paying for it. So, if we are not paying for it directly, if we are not bothered about that, okay, we are making some financial losses while doing all this activity, people does not bother much. Now, that can only be changed when a concern, attitude of concern is developed, and that is the first and foremost objective for making people aware with the economic values of water. So, that will be one of the that is one of the objectives of the course. Then the course will target to recognize major concepts in valuation of water and economic assessment of water related projects. So, what are the concepts, through what means, what approaches the water is valued, what is the value of water, that we will discuss, and how we can economically assess the water related project, that will be the another part. Then to understand the hierarchical governance structure of water management, because water being a so important aspect, so important part of one's life, one need to understand that if I am getting water in my tap, from where it is coming, how many peoples are involved in bringing this water to my tap, what are the governance structure for this, what is the cost that I am paying or government is paying or whosoever is paying. So, all that aspects needs to be understood clearly, and that is one of the objective. Okay. With what are the powers, roles and responsibilities of various stakeholders in the water management, or particularly the governance of water. Then one of the objective would be to develop critical thinking, and so that the attendees, those who are attending the course, can develop that critical thinking and demonstrate some problem solving and decision making skills for managing water related issues. So, that will be sort of when we may discuss some specific case studies, that time these aspects will be elaborated further. What eventually we will study through this course, sort of content of this course, although it will be available to you separately, but what primarily we are going to discuss is onto the water resources availability and distribution. So, what are the national and global perspective onto the water resource availability and distribution. Then the demand and use patterns, what is the demand of water, how much water is being used in various sectors and all that. We will get the quantitative assessment of these things. Then we will also be talking about how we value water, and what is the basically price of water, how water is priced. So, we will have discussions on to valuing water and water pricing. We will also talk about the economics of water projects. Apart from that, the water rights, what is water sustainability, how the water is managed, and what is the governance structure of water, particularly in India. Towards the end of the course, we will talk about the global water diplomacy, conflicts and dispute managements, and some of the major challenges and open issues that needs to be taken care while discussing or while addressing water issues. So, that was about sort of general introduction to the course and its importance, why at first place one should study this, what one should expect while attending this course. So, that was some introductory remarks onto that, and with this we would now come on to the specific topics, as just in the previous slide we were telling that we will discuss several sections one by one. So, what we are going to start with is the availability of water and its uses. Now, if you see, the water in the nature remains in various forms, and as from these days, even from the basic schools, people are being taught about the water cycle or hydrological cycle. So, many of us are aware that there is something called water cycle or water cycle, which sort of informs about the movement of water from one phase to another phase. In this process, what information we tend to get is where water is stored and through which process or which means it can change its storage destination. The storage destination, no storage destination is permanent. Water has some lifespan in different mediums, and that lifespan varies from very small to a very great extent, but it is a cyclic process and water basically changes phases, and that way through various processes it changes phases, quality, volume, everything. The ocean is sort of the biggest storage or biggest, you can say, the sink of water, from where you can take this as a start point or end point, whichever way one sees, and then through evaporation it goes to the atmosphere, where there are cloud formation and the cloud formation takes place. These clouds travel in the atmosphere and then come down to the soil in the form of precipitation, which could be rainfall or snowfall, any form of precipitation. Now, when water comes onto the soil, part of it infiltrates to the groundwater, which again flows or percolates to the ocean eventually through migrating. Maybe there are intermediate storages, it could go to the lake, it could go to the rivers, or it could eventually, like rivers also connect to the ocean that way, but it will eventually find its way towards the ocean, the one that actually goes into the subsurface, infiltrate. So, there is although it is stored for quite some time, and that is what is groundwater, what we refer to. However, part of it from the soil surface itself goes again into the atmosphere in the form of evaporation or transpiration, which is from the green surfaces. So, through this evapotranspiration, part of water again goes to the atmosphere. So, this cycle of ocean to atmosphere to soil to basically subsoil or subsurface again to ocean. So, this cycle keeps on running, okay, and that is how the water moves in the nature. If we have a gross quantitative estimate, what we see is that around 97% of the total water lies in the oceans. So, although there are various agencies and the number varies slightly, not very drastically, means no one will claim that there is only 90% water in the ocean, but somebody says is 97, 97.2, 97.3, and those sort of variations could be there from source to source. Generally what we see that on an overall around 90%, 97% of water is in oceans, 2%, approximately 2% in the form of ice, which is ice caps and glaciers, and of very little water, if you see in the terms of percentage of the total water available in the biosphere, it is only 0.001% that lies into the atmosphere. The global water balance, if you try to see it in terms of number quantitatively, again there are different sources. So, one of the sources that you see on your screen is from Sackler, which was estimated in 1993 in terms of sort of numbers. So, you see that the almost around 410,000 cubic kilometers of water per year comes from precipitation, while 456 leaves in the form of evaporation from the ocean, from the sea surfaces, while evapotranspiration leads to almost just like 61,000 cubic kilometers water, and precipitation brings down to 108,000 cubic kilometers. The atmospheric transport in the form of cloud and all that takes 46,000 cubic kilometer of water. The better estimate in terms of number is provided by the US Geological Survey, which says that you can see on your screen the total numbers over there. So, you see that if in terms of either volume of water or surface area of ocean or the total percentage, almost 97.2% of the water is in the ocean as per the estimation by the US Geological Survey. As we were saying that atmospheric part is very low, then there are the next significant part is in the form of ice caps and glacier, which is 2.15%. The freshwater resources what we have, what is sort of usable freshwater resources, generally we cannot use water in the ocean, although after purification and all that we can, but mostly the ocean water is not suitable for human uses. So, if we discard that, we cannot use the water in the ice caps and glaciers. So, even if we discard that, so 97.2 plus 2.15 makes it 99.35%. So, what we are left with is just around 0.65% of the total water for our uses. And if you see that the fresh water what we primarily use from river or stream is 0.0001, the groundwater is 0.31, and in the forms of lake and all that is 0.01. So, in fact, this is the amount of water, this the one that you are seeing here, this is the amount of water for which all of us are competing. Okay. All of us means not just human beings, our ecosystems also, because our ecosystems are mostly based on freshwater systems. So, the requirement of ecosystem, requirement of human beings, requirement of development, growth activities, all that mostly rely on this, and that is why we say that freshwater is limited resources. There are sort of different residence time of water in the different mediums. If you see that, so the resident time in the ocean varies thousands of years, while in the atmosphere is as low as 9 days. In the river streams it takes typically 2 weeks, the average time by the time it takes the water to the sea or to the ocean. Okay. The largest residence time is in form of the ice caps and glaciers. So, something that goes there does not moves for tens of thousands of years and even longer. Okay. Then Similarly, the groundwater, depending on whether it is shallow groundwater or deep groundwater, you may the residence time varies largely. It may be just 100 years or it may actually extend to several thousands of years. So, that is how the water retains in different mediums, in different systems. So, with this we will end our this first session, and we will see you all for the next subsequent session, where we will continue our discussions from this point forward. Thank you.